Hello, I'm Scott Ramming, a member of the Travel Modeling Unit within the Division of Transportation Development. Working with CDOT's Resiliency program, we've developed an application of the statewide travel demand model to identify optimal detour routes on the state highway system in the event of a needed closure. This information is needed to complete the risk and resiliency analysis for costs of road closures and may be useful for other applications. The Detour spreadsheet provides information on the additional travel time and distance associated with the detour. These are necessary inputs to calculate user costs in the CDOT Risk and Resiliency worksheet. So starting from the Resilience Program website, you can download the Detour tool within the list of tools here. It's the Detour Identification tool. The spreadsheet has an instruction tab that will guide you through the process of finding the information you'll need. Generally, you'll work from left to right, with a few colored tabs being the ones that you'll typically use. Additional tabs provide lookup tables and other information you might choose to refer to in a more complicated situation. Start with the Closure Location tab by entering the route of interest, 3 digits with leading zeros and a letter suffix, and an appropriate mile point of the closure. The spreadsheet has checks that will alert you if you enter a route that's not supported or a milepost that's out of the range. For our first example, we'll look at I-70 within Glenwood Canyon, which is about milepost 125. And this mile point is near the Hanging Lake Tunnels. We've completed the first step of entering a closure location. Next, we'll filter the records in the Detour Info tab to get immediate results for a closure in the primary or increasing milepost direction. The Instructions tab show that to view detours in the primary direction, we'll filter on column P. So that's here and back. Okay, first switch to the Data tab and within the Sort and Filter group, click on the Clear button if necessary. And then we'll set up our filter by clicking on the triangle drop-down of column P, primary match. We'll change the text filter so that yes is checked and blanks is unchecked. Now we can focus on the relevant detour or detours. We can look at detours for 2 other types of situation, where the closure only affects the secondary direction or if both directions are affected. We'll use a different column of the Detour Info tab to find our detour. Returning to the Instructions tab, we'll see that we filter on column Q to get a detour for the secondary direction. And we'll use column R to find a 2-way detour. Now we'll return to the Detour Info tab and find the description of the detour from the statewide model and the estimated additional travel time or distance. We've already set up our filter to find a detour for closure in the primary direction, eastbound I-70. In columns E and F, we can see the range of mile points for where this is the fastest detour on a typical weekday. For this example, a closure anywhere between mile point 116.5, the Glenwood Springs exit, and mile 146, which is the Eagle exit, would result in the same detour. There's a shorthand description of the detour route in column M. It uses the familiar alphanumeric designations for Colorado highways. Looking at this description, we see that this is the southern detour on US 50. If the detour uses an interstate or US highway in an adjacent state, the highway name will include the 2-letter state abbreviation or follow the local practice, such as with YO 230 in Wyoming or N27 in Nebraska. Columns K and L will show the additional time and additional distance involved by taking the detour. With this example, the detour adds about 144 minutes, over 2 hours, column K, and about 35 miles, column L. This is ordinarily what you'd enter to the Risk and Resiliency spreadsheet to calculate user costs. You'll enter the additional travel distance and travel time in Exhibit 313, which could be somewhere along in the supporting information of the Risk and Resiliency tool spreadsheet. Returning to the Detour spreadsheet and looking at the State Detour tab, we can see that for our location is color-coded with a wide red band, meaning that the detour adds 2 to 4 hours of additional travel time, which is consistent with the 144 minutes that we saw in the table here. If we examine this detour route more closely, and I will switch to, and this is the a map of the detour, so it travels through Colorado Springs and Lyman. We see implications of how it was developed for through traffic traveling between Utah and Kansas. Motorists would divert at Grand Junction to take US 50, and then pick up US 24 in Colorado Springs and reconnect with I-70 in Lyman. Since the Denver metropolitan area is also a popular destination, to accommodate these motorists, this detour would need to be modified to return to Denver by using US 285. The travel modeling unit can help with such custom detours, or you can use a readily available tool such as Google Maps to calculate the time and distance on the unused part of the detour, in this case from Poncha Springs to Lyman, and the time and distance on the revised part of the detour, so in this case taking US 285 into Denver and then I-70 to get to Lyman where the original detour rejoined I-70. And then it's just a matter of adding and subtracting the relevant times and distance. Here's another example to illustrate working with detours in both directions. We'll return to the Closure Location tab and enter a point for US 36 between Wadsworth and Sheridan. So that would be Route 36B at milepost 51.5. So consulting the Instructions tab, we confirm that we'll filter on column R for a two-way match. Now on the Detour Info tab, we'll clear any previous filters. And then we'll go to the triangle drop-down at the top of column R, which is labeled two-way match. And again, we'll set the text filters so that yes is checked and blanks is not checked. And in this case, we get two results. Column B gives whether the detour applies for the primary or secondary direction. Column C gives the cardinal direction. Filter columns P and Q also confirm whether it's the detour relates to the primary or secondary direction. The description in column M shows that the eastbound detour would be to go north on Colorado 121, which is Wadsworth Parkway, to US 287 and take that along 120th Avenue and then south on Federal Boulevard to return to US 36. The westbound detour uses the reverse route, which is shown here. Exiting at the Broomfield exit, taking 287 along 120th Avenue and then south on Federal Boulevard. Each detour in either direction adds about 9 minutes more travel time and about 3 minutes more driving distance. That's consistent with the blue category, 15 minutes or less, on the State Detour Map tab. Around there. But you can see in this part of Denver Metro, pretty much all of the highways are coded with blue, so the detour would not be a great duration. It would be 15 minutes or less. Note that the statewide model forecasts a typical weekday during the school year. So if your route is in a tourist area where the peak traffic is on a weekend or in summer or the middle of winter, you may need to make adjustments to the result from the detour spreadsheet. Again, the travel modeling unit can help you develop customized detours. The detours are computed for a passenger car. The Commercial Vehicle Permits Office Cooper website can help identify appropriate detours for large, even oversized or overweight vehicles. Thank you for watching this tutorial. If you have any questions, such as making a custom detour, please reach out to Elizabeth Kemp at the Resilience Program Office, or you're welcome to reach out to me directly. Scott Ramming, thank you.